This is the asynchronous recording for Financial Math Unit 6. Specifically, we will be focusing on reviewing for your final exam this week. We are going to hit a couple highlights from each unit and conclude there. So let's get right into going back to Unit 1. Remember that Unit 1 had a lot to do with percentages. It's where we really got acquainted with calculating things regarding percentages, whether it was changing from decimal to percent form or some other variant like this. So by now you've had tons of practice with that conversion between decimal and percentage form, but I want to remind you a bit on some calculations outside of that. So take a pretty straightforward example. Say that a sweater is marked up 30% from P, its original price. What does it cost now? So remember that when you mark something up, you're adding it on to whatever it already is, right? So the price itself can currently be represented as 100%, right? If something costs, I don't know, say $10, how much of $10 is $10? It's 100%. So the price itself is currently at 100%. They are saying that they are going to now calculate 30% of that value and mark it up that additional amount, and that's where this 130 is coming from. So the real question is if we had some original price, but then we increased it by another 30%, what's 130% of P? Well, we can't calculate a specific number without knowing the value of P, but we can do this symbolically. Convert to decimal form. Remember that 100% of something is just itself, right? So 100% of P is just P, or 1P, right? And it's important to include this coefficient. Students often forget it. What is 30% of P? Well, 30% would just be 0.3 times P, right? The same way if I was working with real numbers, like what's 30% of, I don't know, let's say 50. To calculate this, I would do 0.3, I'd convert to decimal form, right? And then I would multiply by 50. It's the same thing here. I convert to decimal form, I multiply by the thing in question, and that would be 0.3p. So then what's 130% of p? We can represent it as 1.3p. So you can think of that as either converting this percentage to decimal form, or you can think of it as doing it in these two separate pieces and adding them together. So now instead of P, or 1P, we've added another 30% and we have 1.3P. So from here, if you know the value of P, you can plug it in and solve. So for example, if the sweater cost $25, the markup price would be an additional 30%, or 32.50. Now an alternate solution for this could have been to calculate 30% of P, which is 30% of $25, which is equal to $7.50. So we could have said, okay, $7.50 is 30%, so I can add that on to 25, and I still end up with $32.50. So this is really kind of more condensed into one step. This separates it out a little bit. Whichever method works better for your brain is the one to go with. Now another big topic in Unit 1 that I got a lot of questions about is calculating income tax. So I want to run through an example. If you're given a table for income tax, typically they will provide you the specific one you need for any given problem. Then they will tell you what kind of tax you're calculating for. So let's say you're asked to calculate income tax for an employee earning $89,000 in taxable income. One thing to be clear on, they've specified that all $89,000 of this is taxable. Sometimes someone's income has deductions or other things that mean that we are not going to calculate taxes based on the full amount, okay? But in this case, they've said $89,000 in taxable income, so we don't have to worry about any of those extra steps. I can go straight to this bracket. So if the taxable income, which is $89,000, falls here, which it does, right? It's greater than 84,000 but less than 160,000. Then these are our instructions on how to calculate this person's taxes. They will be taxed about $14,000 plus an additional 24% of the amount over 84,200. In other words, however much their taxable income exceeds this number, they're going to tax that by 24%. So let's see what that looks like. So this line here is representing this amount over 84,200. In other words, they're just saying find the difference. So this person's income exceeds that amount by $4,800. So they're saying to take that number and calculate 24% of it. And that's what's happening here. So we're taking 24% of this number, and that's what's happening on that right-hand side here. This 24% of the amount over 84,200, that's exactly what's happening here. Now the other piece of this just simply states 14,382.50 plus. So we really are just rewriting that number and we're adding it to this piece that we had to calculate. When we simplify, we get $15,534.50. So this is the income tax for this employee who has earned $89,000 in taxable income. Now, as you look at other brackets, the amounts will change, but the method is always the same. Truly, just do what it tells you to do. For example, if you look at the bottom bracket, it tells you flat that their tax is going to be this much money, so you would add that, plus 30% of the amount over 510,300. So you would do your calculation like we did here to figure out by how much the person's income has exceeded this amount. Once you got that number, you would calculate 37% of that, and then you would add it to this number here. So pretty much in all cases, you're taking a flat tax amount and then adding some percentage of the number that they've exceeded the bracket by. That happens everywhere except in this top one where they just say, okay, there's no flat part to begin with, you just calculate 10% of the income itself. Those are the two most important highlights, I think, from Unit 1 based on the questions I've been getting and the assignment data I've been looking at. Now let's look at a quick review of one of the topics I think will be handy for you to refresh yourself on from Unit 2. Remember, with exchange rate, these questions can be asked in many ways. I always recommend to simplify things so that you have an exchange rate that's talking about one to something else. Let me explain what I mean. In this question, it says that the exchange rate of $2 to euros is 1.8. So we have this ratio here of 2 to 1.8. This makes calculations a little more difficult. So what I want to do is, it's called normalizing. We want to normalize, which will make our calculations easier, such that we're expressing, again, a ratio of 1 to something else. So they ask us how many euros is 34 US dollars. Okay, there's more than one way to calculate this, but here's what I recommend. They've given you this conversion. I can simplify this and say, okay, well, if 2 US dollars is 1.8 euros, then if I divide both sides of this by 2, then 1 US dollar is equal to 0.9 euros. Now keep in mind, this means that in this case, we're saying that the euro is actually kind of stronger than the US dollar, right? So you can get something for 90 cents in euros that would cost you $1 in US dollars. Now once you've done this is kind of like our normalized conversion rate. Once you've done this, we can then calculate how many euros is 34 USD. We can do that by multiplying by 34. So I've done times 34 on the left-hand side, so we say, okay, well then that means that 34 US dollars is equal to 0.9 times 34, which is 30.6 euros. With exchange rate, there's no specific formula that you're provided with to use. Instead, rely on context. Think about whatever method makes sense to you. For example, you didn't have to do this step that I did here. You could have instead, done your calculation based off this right here. That would have been fine. So you have to think of the method that works best for you. Don't cookie cutter, copy paste the way you do one problem to the next. Make sure you always read the context and apply a fresh approach to each problem. Checking balances is another topic I had quite a few questions on from Unit 2. This is a matter of really being able to parse a paragraph of information, because the calculations are usually just addition, subtraction, and then some basic multiplication and division. So what gets confusing is making sure that you understand what the vocabulary means in terms of the math. So Billy had an account balance of $500 in her checking account. Over the next month, she deposits $150, pays her annual credit card fee of $100, and makes ATM withdrawals of $200 and $90 from an ATM that charges $250 per transaction. What is her account balance at the end of the month? So essentially, we're just keeping track of her balance through all of this, and I would just look at it chronologically. So if we look, she starts with an account balance of $500. So you could start there and say, okay, she's got $500. She deposits $150. This means that she adds $150 to her account, but then she makes a payment of $100. A payment, of course, is a withdrawal, so we subtract that amount. Now then it mentions these ATM fees. Let's change colors here. So she makes ATM withdrawals of $209 and then $90. So we're going to subtract $200 because it's a withdrawal, and then we're going to subtract another $90. But these ATM withdrawals were made at an ATM that charges $250 per transaction. So how many transactions are there from the ATM? 1, 2. So we need to also account for $250 times 2 transactions that we are going to subtract off as her ATM fee. So here's our problem all set up, and then it says, what is her account balance at the end of the month? So now I just need to simplify, and I get $255. So recognize here what vocabulary is associated with adding and what vocabulary is associated with subtracting, okay? So things like deposits means plus, or if she was to get paid or something like that, or if she transferred money from another account, all of these would be signs of addition. Any sort of fee, transaction, withdrawal, all of these things are things that you subtract. Now, just a quick pause here. The first letter of the code, it's going to be 3 letters this week. The first letter of the code is capital H as in horse. Capital H as in horse. Okay, let's move forward and quickly go over some of the main points of Unit 3. This example is about calculating how many months it takes to pay off a credit card balance. Now, if you remember, this is the equation that has logarithms in it and has quite a few numbers to punch in and quite a big chance of being able to make a typo as you enter something into a calculator. So let's take a moment to review an example. So Meryl buys new baseball equipment for $2,000. The purchase is made with a credit card that has a 19% APR. Meryl makes a $150 payment monthly. So how many months will it take Meryl to pay off this balance? Now, our assumption here is that he's not adding anything else onto his balance, that he's just paying this off. This is the equation associated with figuring out how many months it takes to pay off a credit card balance. Now, to be clear, this N, number of months, assumes that we're talking about credit cards and that we're talking about something that's compounded monthly. And it also assumes that we're making payments monthly. So this is a specific equation for a specific situation, okay? If this were something, some other item besides credit cards, like just an account that someone was making payments to, we wouldn't necessarily be able to use this equation. It would have to be under the same conditions with the monthly compounding and monthly payments, okay? Now, the equation is n equals negative log of 1 minus r over 12 multiplied by p over m divided by the logarithm of the quantity 1 plus r over 12. Let's think about what our variables are. I would say let's just look at the numerator first, just the piece in that green box right here, okay? So 1 minus r is rate, in other words, the APR. That rate is 19%, but we switch it to decimal form of 0.19. So I plugged in r divided by 12. P is this principal of $2,000, and that gets plugged in here. Divided by M, the monthly payment that he's making. So notice that we've got many things kind of related to months and time happening here. So N is the number of months of payments he will have, while capital M is the monthly payment amount, okay? So capital M is that monthly payment amount, and they've said that it's a payment of $150, and that gets plugged in here. So again, R is the rate, the APR in decimal form. P is principal. M is monthly payment amount in dollars. So simplify all of this. 1 minus the quantity 0.19 divided by 12 multiplied by the quantity 2,000 over 150. I simplify it to 0.79. Great. Pause there. Keep going. Let's now talk about what's happening in the parentheses within the denominator. So not dealing with the logarithm yet. So I've got 1 plus r over 12. Well, we already know that r is 0.19. Pretty quickly we can simplify that to 1.016. Now let's deal with the logarithms. So I plug in the results we got. This 0.789 I've plugged in right here. This was the piece that we solved for. This 1.016, same thing in the denominator. Now at this point, you have two options depending on what kind of calculator you're using. So one, you can plug this in and solve it as is, or two, you can still separate and do the numerator first and the denominator second. And then once you've simplified those into normal numbers with no logarithms, do the division and get your answer. So I got 14.9, which means he has to make 15 payments. Remember, when it comes to problems like this, you have to round up no matter what. So even if this number had been 14.1, it's still going to take 15 payments. Why? Because they've said that 14 payments is not enough. 14 payments of $150 won't be enough to make payments. There's no physical way for him to make a tenth of a payment, right? So what this does mean is that his final payment, his 15th payment, will be for less than $150. That's what that means. But he still has to make that 15th payment. So about how much will he pay back in total? Well, we could estimate this by taking his monthly payment amount times the number of months. But remember that on that number 15 payment, he's going to pay back a little less. So approximately, he's at $2,250 total. Now, if we wanted to know the exact amount of money he was paying back, we would use the compound interest formula, but that's not really an emphasis, an equation that I want you to spend a ton of time working on. So don't worry about that so much. All right, Unit 4. Unit 4 had a lot to do with annuities, and it introduced many, many variables and equations. They're presented in a nice table. I think the table is in lesson 16 if I'm not mistaken, but I refer to it in my Unit 4 session. Please use that table. Use it during your exam. You can print it out if you want to and refer to it. Remember that one of the big things about these equations is that not every letter individually represents a different variable. So for example, this FV sub t stands for future value for t years. Okay, it's just a way of abbreviating the notation so that we don't have to write out a whole sentence to explain what we're talking about. So although it's 3 letters being written, it's only one number that you're going to have. Same thing in the right-hand side here, this PVIF sub RT, this is one number. Okay, so keep that clear. And the thing is that they usually hint to you, you know, PV is present value. The things that you see in the left-hand column that are the things that you're solving for are the things that end up being abbreviated in the equations. Now, one thing that I cut off here is that this left-hand side column is based on formulas, and this right-hand side is under the conditions that you're given some value from a table. Now, as an example, for this PVIF sub RT, this is a way of saying that the present value, or representing rather, a variable for present value at a rate of, you would specify a rate, in this case, for this one, for example, it's 9%, and a time of 4 years. And again, the point is just to be compact. This is a very short and easy way of saying something that would take, you know, 2 sentences to actually write out. Now, let's do a quick example. At the end of 7 years, an investment with a discount rate of 12% is worth $300. What is the present value? You would grab your present value equation. Now, if they've provided for you this number from the table, right, this is if you're given info from the table, you can just plug this number right in. So they've given you PVIF for 12% at 7 years, which is exactly the conditions of the question, right? It's 7 years and 12%. So this is a shortcut, and they're saying you can take this number and plug it right into the equation. So that would be happening right here, right? This number they're saying is equal to 0.5908. Plug that in. And then the other thing we have to plug in is that they mentioned that at the end of this time period, so that's in the future, the future value is $300. So future value after 7 years is $300. We plug that in. What is the present value? In other words, the initial value after 0 years. We just do 300 times 0.5908, and I get $177.24. So that's the answer. So I think this is a pretty complicated looking equation, but it all just turned out to be quickly multiplying 2 numbers. Now, if they do not provide this number from a reference table for you, you have to do it using the equation, but don't worry, it doesn't take that much longer. Notice that if you didn't have this number, the stuff inside the parentheses just becomes 1 over 1 plus r raised to the t. So you would just need to know the rate and the time, right? So in this case, the rate was 12% and the time was 7 years. So you could have quickly solved for that instead. And it's still being multiplied by a future value for some amount of time. The second letter of the passcode this week is O, as in Oreo. That's a capital O, as in Oreo. All right, Unit 5. This should be much more fresh in your head. Let's just do one example and talk about key points of picking out the best health insurance policy. Say that Jolene is a 31-year-old woman who has experienced recent jaw pain. Which policy is best for her? Anytime that you are given some sort of specific medical concern they have, for in this case jaw pain, take it as a hint that you need to make sure to do something specific to address it. So in this case, jaw pain is going to be something relevant to a dental coverage. So we're going to look at dental premium per month, okay? Now, it's not a matter of which one's cheaper yet. It's just a matter of saying we want one that includes that coverage. Remember that in these cases with this type of table, when it's talking about premiums, if the word there is listed as none, it means no coverage. Okay? For premiums, if it says none, that just means no coverage. So in this case, policy B and policy D are not going to be good for this person because they don't have dental coverage. Next, we can say, all right, there's this $35 dental premium per month versus a $40 dental premium per month. Does anything else matter to us at this moment? They don't mention any other specific concerns, because notice that one other difference is this vision, one's covered and one's not. So in this case, since they didn't mention specifically needing vision coverage, I would just total up the policies and go with whichever monthly payment is going to be less. Now, quickly glancing at this, even if we just do a point-by-point comparison, this premium is way lower than policy C, right? $375 versus $550, considerably less. Now, of course, you end up having to pay the $42 extra, but that still doesn't even add up to $550 total, right? Co-payment none versus $30 on this side, and the deductible is lower. So this one is clearly cheaper. Of course, you'll want to do your addition and double check. Policy A is clearly the cheapest plan that has dental included. So policy A is going to be best for Jolene this time. Now, remember when it comes to picking the best health insurance options, if plans cost the same, compare deductibles. And by that I mean if premiums cost the same, compare deductibles. Again, as I mentioned in the last slide, if they mention a specific health concern, eliminate any plans that do not cover that concern. That's item 2. Don't worry about this last one. That's more about life insurance. And then, again, when it comes down to it, sum up the columns and just see which one is less. Okay? I think that's kind of the best approach in many cases. Sum up the columns, see which one is the lowest. Now, same thing goes for Unit 6. Okay? There's more practice with picking policies. In this case, it's talking more about like work liability, work insurance, and things that employers would have to purchase for coverage. So if I just look at this one, and I haven't even provided any context here, but if I look at a table like this, I can quickly see, okay, I've got 4 policies. One of them has, one thing is property insurance, vehicle, workers' comp, and interruption insurance. But notice that all 4 items are covered in all 4 policies, okay? So then they haven't given us any other information, so we can't compare, for example, quality of coverage, right? We can't say, well, maybe the more expensive one is a better one. We don't have the information to support that. So at this point, if I have a table that has policies where across the board they're offering theoretically the same coverage, then the only thing there is left to do is just to sum up each column and see which one's the cheapest, and that's going to be the best option. It'd be a different story if, say, policy A didn't have property insurance, or policy B didn't have vehicle, or maybe C and D don't have interruption insurance, right? Then we would need context to kind of figure out the best one. But in a case where everything is being covered in every policy, it just comes down to the numbers, add up all the columns, whichever one's the cheapest is the one to go with. So before you take your final exam, I want to make a couple suggestions on how to study. Now, I don't expect you to do every one of the following items, but maybe picking out 1 or 2, try them out, figure out which one's the best one for you, and which one actually makes you feel like you've studied something. Okay, you don't want to just do an option where you're kind of going through the motions but not really taking in any information. That's just going to waste your time. So pick something that's going to work for you that you can focus on. So one thing you can do, review your notes. If you're the type of person that takes notes, takes organized notes, you can read them out loud to yourself, go over tricky concepts or problems, or even just going over earlier ones that you haven't seen in a couple of weeks. If you need something a little more hands-on, go in and pick your lowest checkpoint from each unit, and redo it. Especially in Unit 1. It's been, 5 weeks since Unit 1, right? So go into Unit 1, pick wherever your lowest checkpoint happens, and just retake that. Or pick your lowest workbook and retake that, okay? You could also do this by unit. Like, say you really aced Unit 1 and 2, you don't want to revisit them, that's fine, but maybe you struggled in Unit 3. So then concentrate your time in Unit 3 where you need it, and maybe just redo all the Unit 3 checkpoints, something like that. And if you choose this plan, this one's nice because not only are you studying and practicing and being hands-on, but if you're redoing these assignments, it's going to improve your grade. Make sure you do any of the missing sessions, these very sessions that you're listening to right now, okay? Remember that you have 2 tries on any of them. So if you've taken 1 try but you're not happy with your score, you can watch the video again and take a second try. I will say that I don't think it's worth doing a second try if you're not going to rewatch the video, since the quizzes are 100% based on what I say in the video. So don't just go in and take a second try unless you refresh your memory by watching the video. Something else you can do if you feel pretty confident but just want a quicker review, just go back over your unit exams, make sure you understand how to solve those problems still. Maybe you could just pick out the ones that you missed and you could rework those. Spend time in lesson 30. So there's actually, this is a review lesson, it's not a real lesson. Okay, so spend time in lesson 30. It goes through kind of as I did, but more in depth, a couple of unit highlights from each unit to help refresh your memory, especially on vocabulary. Now, since vocabulary, this isn't something I always recommend for math classes, but I think it's very important for this one. Vocabulary is huge in this class. I would say 2 out of 3 questions I get aren't because students are struggling with math, it's because that they've misunderstood or forgotten or just aren't sure about a vocabulary concept and what it means for the math problem. So, reading through old discussion board posts and redoing any as necessary, it would be a great vocabulary refresher. If you read a prompt and you don't understand what it's asking, or you do understand but you don't know how to answer, that's a hint that maybe you need to go back through and reread old vocabulary. And just like I said in the second point here, if you were to read through these and then just redo any that you didn't get 100 on, not only would you be studying, but you would be improving your grade at the same time. So it's a total win-win. So the final letter of the passcode this week is B as in boy, or Bravo. Let's say Bravo. So capital B as in Bravo is the third and final letter of the passcode this week. Best of luck on your final, and thank you so much for tuning in each week. I wish you luck going forward in your future classes. Thanks, guys.